Okay. We're going to go through what's considered a complex fearless factoring question. The reason it's complex, if we look at this, there's a lot going on here. We got in terms of BEDMAS, we got some brackets to deal with, then an exponent, then some multiplication, then addition and subtraction. I mean, let alone if I was to expand this, was tricky, let alone trying to factor this. So because this looks complex, a method to do is if we can make it a simpler type question. So what we're going to try to do is find something that is the same multiple times in the algebra and replace it with a simplistic variable. So in other words, we're looking for something called a let statement. So if I take a look here, I got my brackets. They're complicating things, but I can just rewrite them. Let's say let y equal x plus 2. Okay? So now when I go rewrite this question, I have 6y squared plus 7y minus 20. This version of the question is much easier to look at. If I quickly go through my fearless factoring here, 3, 2, 20's got a lot. 120, 2, 10, 4, 5. We need two products of this. Whoops. Looking for our two products that are going to add to our middle term here, which is our 7y. So we test our two columns. And I think I've done this one before. I'm pretty sure we did this one before. So I'm actually going to cheat. I'm going to jump and do the reverse, which is a systematic way to do it. I'm actually going to start with the second column and go from right to left. The reason I'm going to do that is I get the feeling it's going to be this column as opposed to this column for the fearless factoring. So don't forget there is a negative here, so that's going to be important. 3 times 4 gives me 12. 2 times 5 gives me 10. No adding or subtraction gives me 7y, so that's not the version. But let's crisscross and find out. There it is. 3 times 5 is 15. 2 times 4 is 8. The difference of those is 7. Okay, and we have a negative 20. So if I make 8 negative, 15 minus 8 gives me 7, which means this 4 needs to be negative. So we move to the second piece of this. We know we're going to end up with two brackets. And we used this column here, so we did not use this, we did not use this, we did not use this. I can just have a visual for myself. 3y and the 2y are the first terms in each brackets. And then we just got to make sure they're in opposite brackets of what we multiplied by. So the 2y and the negative 4 have to be in opposite brackets, so the negative 4 goes here, which means the positive 5 goes here.
And then just replace that one.
That's it. Now, this is good. We've done the factoring, but we set a let statement in here to simplify the question. So I'm going to rewrite it so that my reader knows, okay, I'm now substituting back in x plus 2 for my two y variables. So when we go through that piece, we got 3 times, so we're replacing that y with x plus 2 minus 4, and then 2 times x plus 2 plus 5. We do a little bit of distribution here. And we end up with 3x plus 6 minus 4. We do a little distribution here. We get 2x plus 4 plus 5. And then we get to the final part of this question. We get 3x minus 2 and 2x plus 9. So while this looked like it was going to be a very complex version of factoring, because it was hard, we did something to simplify the question. Once we simplified it, we worked out our algebra or algorithm for factoring. Then we plugged back in, which made it slightly more complex, but not so bad that if I had to try to factor it this way, this would have been much harder. We expanded, and that's it. We stuck with our final factoring, our factored form of this original question.